So welcome. In this project we will be dealing with serial communication. People ask, what is serial communication? What does it do? Where is serial communication applied? We will explain this further as we go into the project, and we will do some examples of projects under serial communication. So what is serial communication in wise of telecommunication and data transmission? Serial communication is a process of sending data one bit at a time sequentially over a communication channel or computer bus. From the picture here, you can see there's a sender computer and there's a receiver computer. So it sends data one bit at a time from one computer to the other over a communication channel or computer bus. So coming down to serial communication in Arduino, it simply means to transfer data in series to another device. In Arduino, we can do serial communication either with a computer or some other devices via USB plug and the TX and RX pins of Arduino. The serial communication in Arduino is done through the pins which are dedicated for this purpose. As you can see in the picture, the TX and RX pin have been highlighted red, and the port for the USB plug also has been highlighted. So we'll talk more of this serial communication in the introduction. So welcome to the introduction of this project. So we've defined serial communication in Arduino. Now going further into a further description of it, or another definition of this serial communication, it is a communication technique used in telecommunications wherein data transfer occurs by transmitting data one bit in a sequential order over a computer bus or a communication channel. It is the simplest form of communication between a sender and a receiver, as shown in this picture. A simplest form of communication between the sender and the receiver. Now in serial communication, data are sent over a single line from a transmitting device to a receiving device in a bit serial format at a pre-specified speed, which we know as the baud rate, or the number of bits sent each second. The typical example of baud rates we have are 4800, 9600, 19200, that's 8400, and etc. Now in serial communication, a minimum of 3 lines are used for communication. These are the transmitting line, the TX, receiving line RX, and the ground GND. Now taking a look at the Arduino board here, you can see the TX and RX, and the ground pins are also there too. But for this project, the ATmega328P series of microcontrollers, their serial communication can be handled either in the hardware or in the software. The use of the hardware option is easy because the ATmega328P series of microcontrollers have built-in universal asynchronous receiver transmitter, which goes with the short form UART. Now these circuits provide special input-output pins for serial communication. For serial communication, all the data transmission is handled by the UART, but we have to configure the UART, which is the Universal Asynchronous Receiver Transmitter. We have to configure it before receiving and transmitting data. But with the software option, all the serial bit timing is handled in software, and any input and output pin are or can be programmed and used for serial communication. In this project, we will do a lot with the serial communication. This is a picture of the Arduino board. Now in the picture, we can see the pin 0 and pin 1 are specified with the TX and RX, that's the transmitting and the receiving. These are used for serial communication. Also, a USB plug is present for the serial communication with the computer. There are different types of boards there are different kind of boards for serial communication, but every board has at least one UART, or you can also call it USART port. This is the Arduino IDE picture. The output of the serial communication can be seen on the serial monitor, which can be accessed in the Arduino IDE by clicking the serial monitor in the drop-down menu of tools as shown in the picture, or you can click the icon that looks like a magnifying glass on the top right corner of the Arduino IDE. You can see it in the picture. It has serial monitor written beside it. So these are the two ways you can access the serial monitor. Now we are going to run through an example of this serial communication before we begin the project proper. For the example, we will use the begin function for the serial communication with the computer through the USB plug of the Arduino and set the speed of transferring data, which is the baud rate, at 9600. Then we will use the simple print function to print the text. The text we will be printing is "Welcome to this project" in a serial monitor. For this purpose, we will use the following code for it.
Audio Jungle.